Good morning, everyone, and thank you for joining us for today's webinar. My name is Jean-Pierre Picard. I'm Product Marketing Manager at CM Labs, and I'll be your presenter today. With me on the line is Marc-Alexandre Vizna, Product Manager for the Vortex Software Solution product line at CM Labs. He'll be giving live demonstrations throughout the presentation. Today's presentation will last about 45 to 50 minutes, and we will conclude it with a Q&A session, at which point we'll take a public question. This session is being recorded and will be made available on CM Labs YouTube channel somewhere early next week, and we'll make sure to send you every one of you a link to see it after it is made available. So let's get started, since we have a pretty full session today. We've split it in a few sections. First, we will spend the bulk of the presentation looking at new features introduced in Vortex 6.6, but also in 6.5, which was released earlier in 2015, and for which no webinar had been held. Then we'll intercut this with live demo portions of the main features that were added to Vortex Software Solution. We will then cover the samples and documentation available with Vortex, and as I mentioned, we'll finish the session with a Q&A, taking questions asked through the chat. Now, if you want to ask us a question, simply open the chat box on the right side of the GoToWebinar interface, enter your question, and make sure to select Organizer so we know that you want to send this question for the Q&A at the end. So let's get into the meat of it. Today's session is jam-packed with new features. We split them into 4 categories. The first is Vortex Editor, which is groups of features that have been added to the Vortex Editor application. Amongst those, mainly the CAD Optimizer Add-On and the Graphic Gallery, which we'll cover in an instant, but also a lot of enhancements that were brought in 6.5 to Python scripting and shadows. Then we'll move on to Vortex add-on enhancements. Add-ons such as Earthworks, Cable, Marine, and Vehicle add-ons. We'll spend a bit of time talking about the Vortex Player application, and we'll finish with an overview of additions to the simulation frameworks, which are available through the Developer SDK. So if we start with the Vortex Editor, the first feature I'd like to talk to you about today is the CAD Optimizer Add-on. For those of you who have used Vortex before 6.6, you'll know that to create a mechanism, you had to start from a 3ds Max file, which could then be imported and turned into an interactive mechanism. For some users, especially those in the engineering world, this wasn't the most efficient way to take existing assets and bring them into Vortex. And the CAD Optimizer Add-on aims at improving the pipeline for those of you who use CAD to create 3D models. So the CAD Optimizer enables the use of 3D CAD models directly in the Vortex Editor. So it includes import functions, but also optimization functions. It's really aimed at the engineering space, and the goal is to go from the design to the interactive virtual prototype phase faster. We support with the Vortex CAD Optimizer Add-on 3D XML files, STEP, JT, SolidWorks, and STL CAD assets. So all of these can be imported directly into the editor. And then you can take the model and simplify it, streamline it, and make it ready for simulation. Those who are familiar with engineering-grade CAD models will probably know that they often have more details included into it than are necessary for accurate real-time simulation. Elements that are there for assembly purposes, such as bolts, nuts, holes, all of those things, they don't affect the actual performance of the virtual prototype, but they take resources away when you're running your simulation. So the CAD Optimizer Add-on includes a suite of simplification tools that allow you to remove those details that don't affect performance, but that that affect performance but of the simulation, but not the one of the virtual prototype. So we'll go through a few of those in a live demo in a moment to show them in action. But what it allows you to do is to go from a complex CAD with a lot of details, such as this one, where you have a lot of different geometries, vertices, and primitives, to one that you can cut these aspects by 50 to 90%, depending on the complexity of the model. So to show it in action, I will pass the mouse to Marc-Alexandre.
The CAD importer is accessed via a new file type called the Graphics Gallery, which we'll examine in greater detail later. For now, let's just open up a new gallery. To import a CAD file, simply click on the 3D CAD Model button. We now select the step file that we want to import. At the bottom of the screen, there are entries to change the axis and the unit of the model. In this case, they're already correctly set, so let's import our model. We now have an animated logo that shows you that the computer is working. When the model is loaded, the graphics node will appear in the left-hand Explorer panel, while the properties will appear in the right-hand panel. The model itself will be displayed in the viewport. The model is now loaded in Vortex. If we expand the Explorer panel, we have a list of all the nodes in the model, a folder for the meshes, and a folder for the graphics material, which determine how it will react to light. Let's go back to the nodes. We can use the Colorize Node button to get a better idea of what we're up against. The computer has assigned random colors to all the nodes in the model. There's way too many of them. We don't need all of those for simulation, so we're going to merge them together to reduce them to a manageable number. By right-clicking, you can access the tools of the CAD importer. In this case, we're going to use the Merge Graphics Node tool to merge the various nodes that we have selected into a single one. We can repeat the operation as much as we need in order to reduce the number of graphics nodes to something that is more manageable. The CAD importer also includes a number of tools to simplify the model by removing parts that are not useful for simulation. In this case, we don't need the entire axle since it's mostly hidden. However, we're going to need to keep the end cap for the wheel. Let's isolate this part. Now that we have only the axle, we can select it, go into the tools by right-clicking, and use the Split Geometry tool to break it down into smaller nodes. The computer was not able to recognize smaller nodes, but all is not lost. We have a second tool called the Split Edges tool, which is going to split the model based on the edges. Much better. This time, the axle has been broken down into smaller nodes. I simply select the nodes that I do not need and delete them. Bringing back the entire model with the Show All tool, we still have our end cap, but the hidden axle is gone. We can also directly select nodes and delete them, or move them, or duplicate them as we need. The CAD importer has a number of other tools that are very useful. In this case, the measuring tools allows us to measure the size of various items. I want to get rid of those holes. I don't need them. So I select my part, access the Fill Hole tool, specify that it's hole, and then specify the diameter that I need. And now the holes have been removed from the mesh. Bringing back the entire model. There's now no hole. If I remove the bolts, there will be no holes in the wheel. Back to you, GP.
So the graphic gallery is a new document type that is coming as an extension of changes that were done in 6.5. So in 6.5, some of you might be aware that we've changed the way that Vortex deals with with 3D models, instead of linking to an external model, we've started importing it and converting it to a model extension in the mechanism. And then that made the 3D model file no longer required after the import. This was good, allowed some easier sharing of the model, but it did include some drawbacks going from an XML to a binary file format. But this opened a lot of options for us to be able to manage the model directly in Vortex, and that is what the graphic gallery is. It's the next step in that evolution. This new document type allows you to edit the model structure and the visual properties directly in Vortex Editor, something that you had to do in external program previously. Now, the advantage is that this allows you also to edit the visuals and the mechanical properties in parallel. So this allows you to advance on both fronts at the same time, reducing the cycle time to create an interactive mechanism that is optimized for Vortex visualization. The graphic gallery brings several features to it, such as the ability to add or change graphic materials, adjust bump and specular values, set the blend mode, and there's a lot of hierarchy addition features as well. So we're going to go through a demo of the other graphic gallery features that are not related to the CAD Optimizer with Marc-Alexandre.
Let's take a look at the new file type, the graphic gallery. It can be accessed through the new button at the top left of the screen. Simply select graphic gallery and click OK. This is a blank graphic gallery with the Explorer panel on the left, a property panel on the right, a viewport in the middle, and a toolbar at the top. We can import 3D model inside the graphic gallery by selecting it in the property browser. We now have loaded our model inside the graphics gallery. Expanding the Explorer shows us a connection container between the various nodes, a list of nodes that comprise the model, a graphics geometry folder that contains the meshes that make up the model, a graphics material folder that contains the graphic material that determine how the model will react to light, and a texture folder where the texture used by the models are stored. There are a number of tools accessible. In this case, we'll still use the Colorize Node tool to show us what the model is made of. There is a separate node for the side panel and the hull, but we don't really need the side panels to be a separate part. So we're going to merge them with the main body to have a single node to cover everything. Let's try again on the turret and the side basket. This time the computer did not merge the node because they do not share the same graphic material. Let's take a look at the graphics material then. These determine how the model will react to light. In this case, we have access to a number of shapes to help us see better the lighting effect on the texture. There are a number of fields that are accessible to adjust the bump amount, the specular, the shininess, control how the transparency or alpha channel will work, and then a number of slots to put in textures. There's a new space available to put in emissive texture, which are self-lit texture, which allow you to do stuff like lamps and headlights. Another new useful feature is assets instancing. In this case, let's take a look at the wheel. The geometry is stored here. If we take a look at the second wheel, it has its own mesh, but it's exactly the same as the first one. Let's try and change it so that it points to the mesh of the first wheel. Both wheels now share the same mesh. However, they appear separate in the model. Let's do this again. Now all three wheels are based on the same mesh, which occupies less space in memory, yielding a more efficient model. Now let's clean up a bit. Using the new Remove Orphan feature allows us to remove all the geometry, texture, and graphic material that are not used or connected to the model in any way. Deleting all allows us to clean up without having to undown specific files. You can now save your graphic gallery and use it in the mechanism just like you would a model in the old ways. GP?
Thank you, Marc-Alexandre. So this is really a great improvement into the different capabilities you can actually manage a model in Vortex. By adding asset instancing control in the graphic gallery, by adding material controls and hierarchy addition capabilities, it means that you can actually fine-tune your visuals and optimize your model directly in Vortex. It streamlines the creation process greatly. So the next feature I want to talk about is the addition of two new automatic convex collision geometries decomposition algorithms. Some of you, those of you who are familiar with creating collision geometries, will know that creating the collision geometries for convex shapes can be tricky. These new algorithms, called HACD and VHACD, allows you to create more precise collision geometries automatically instead of manually. So it will save time because you don't have to do manual work, but it'll also increase the accuracy of contacts. And the best way to explain how it works is to show a direct example. We're going to look at our EOD mechanism, which is included in the samples of Vortex 6.6. And more precisely, we're going to look at one of those gripper arms on the model. So in 6.5, if you were using the automatic convex geometries decomposition algorithm, which was called Convexol, you would get this result. The way Convexol works is that it finds all the outermost points of a shape and links them together in one collision geometry. Now this really won't do, because if you look at the inside portion here, this is where you're actually going to have contacts with materials you're grabbing with the gripper. And if you have two of these next to one another, you have no room in between them. So you're going to have very knackered collision geometries. So that means that you'd have to create it manually using primitives. In this case, for example, capsule primitives. This is a lot better because you get the actual shape of the gripper, but you're still missing some parts. You're missing the handle, you're missing a bit of the tip here, and you're missing the cups in the middle as well, which are part of the design of the gripper. In 6.6, if you use one of the two new automatic algorithms option, you will get a result that is a lot more precise, as you can see here. So the way it works is that it decomposes the shape in multiple convex shapes. So for example, it can create a convex shape here, one for the cups, and then it merges them all together automatically. It's more precise. You can see that it actually matches the exact edges of the gripper, but it's also less work because this was done automatically, computed by the system. Another improvement in 6.6 is the addition of integration to speed tree assets. Speed tree is a vegetation modeling solution that is available for professionals. And what we did is we've added support for assets created in speed tree, but we've also added 35 free speed tree assets as part of Vortex Editor. So that means you can add those assets directly from the interface, no work required, and you can scale them in the Scene Edition interface. This is great because it allows you to easily make scenes a lot more immersive. It allows you to create forestry scenes that are a lot more realistic, that will place operators in a situation where they will act exactly as they would in a real forest. also allows you to just enhance the fidelity of other scenes and make it so that you can control the vision of a driver, for example, in Driver Simulator, or just make it look better, more engaging. So just to show you the result in the editor, we're going to look at the new forestry sample that is shipping with 6.6. So I will pass back the control to Marc-Alexandre. So Marc-Alexandre.
The Forestry Forwarder is a brand new sample that is included with Vortex 6.6. It showcases a complex vehicle application as well as the new speed tree feature. Let's use the new speed tree functionality to incorporate the tree into the environment. Let's add a tree to the environment using the new speed tree functionality. Simply select the speed tree button, access the tree library. In this case, we're going to select an American beech model and confirm. The tree has now been added to the Explorer. Using the right click, we center it in active view. The tree is now located at the origin of the world. We're going to use the move button to bring it into our scene. It's also possible to use the rotate button to place the tree as we need it. There is also a scale factor that's built in to allow you to modify the size of the tree according to your needs. A little large. Let's try again. Much better. Back to you, GP.
Thank you, Marc-Alexandre. So as you see, the integration of speed tree assets is a great way to really quickly enhance the scene's visual realism. And it's really easy to just add a tree, scale them, and with the asset instancing, it means that those trees are not taking too much of your processing capacity either. So the last feature I'd like to look at from an editor perspective in 6.6 is the addition of Collada pipeline. So as I mentioned early on, previously you could import 3D models from in the 3ds Max format. Well, with 6.6 you can now import models created in the DAE format. And that means that beyond 3ds Max you can now use a very high range of 3D modeling and rendering software. Among over 40 programs support the Collada pipeline, and these include all the market leaders. Now, if we look a bit further back to Vortex 6.5, there were a lot of very interesting features added to Vortex, especially to the editor. So the first one I'd like to talk about is the profiler. So the profiler, what it is it's a new panel that allows you to analyze Vortex application to see where processing time is spent and how much time each model is taking to execute. So this is used to improve the performance of your simulation. If you realize, for example, that it's not running at the frame rate you are expecting, or to let you know maybe the kind of processing that is required by one model that could be the bottleneck. So this is a great addition to streamline the fine-tuning and the Q&A process. 6.5 also saw the addition of enhanced Python scripting, and one of the main changes was that the syntax was changed to better match the C++ API available with Vortex. It also supports Python IDE, but the syntax improvements go beyond just better matching with the C++ API. It also simplifies the syntax, the way you access different elements. So if we compare 6.4 and 6.5 scripts, you can see that it actually gets a lot simpler. You used to have to know if you were accessing an input or an output, but also the type of value you would be getting. Was it an integer? Was it a Boolean? You had to know this, and you had to type this in your Python script. With 6.5, that was no longer needed. All you need to know was the name and the type of the element you were getting. So this makes creating Python scripts a lot more efficient. Vortex 6.5 saw some good improvements as well on the lighting front. The number of dynamic light source was upgraded from 8 to 128 light sources. So this makes for a very big difference. We've also changed the shadow visualization components, and we now support cascaded shadow maps. So this improves the shadow rendering, especially when you have large shadows that are casted by, for example, by buildings. It means that before you had some uneven edges, for example, but now it will be a lot smoother and will match a lot better the buildings and the scene itself. So this concludes our tour of Vortex 6.6 and 6.5 features in the editor. Let's move on to the next section, which are the improvements to Vortex add-ons. So starting with cable systems, 6.6 saw a minor improvement, which was the addition of a generic cable ring mechanism, which allow you to replicate machines with cables passing through rings. For example, tethers on ROV, which go through rings here. It's also what would be used if you were to model, let's say, a zip line, for example. But 6.5 saw major improvements to the cable modules. The main change was the addition of dynamic properties that were closer matched to what mechanical engineers would be familiar with. So before, we were using mechanical properties that would be more familiar to the academic world. Now, we've decided to add properties that mechanical engineers would be familiar with, the type of properties that you would find in documentation about cables. And then in the background, we use those values to compute the parameters that are used by the simulation. This makes it a lot easier to model specific cable properties. The way we simulate long cable also changed drastically. With the addition of adaptive cable simulation, we've moved from the very resource-intensive way of Vortex 6.4 for cable simulation to one that takes into account the presence of collision geometries around a cable and assigns computing a refresh rate that varies based on that state. Cable that is not around anything that would generate collisions is put in a dormant state and is updated less frequently, is refreshed less frequently, saving a lot of processing power. Cable that is closer to other objects that create collision will be refreshed more frequently. So you will maintain the accuracy, the fidelity that you had, but it will be a lot more efficient. And this is done automatically by Vortex. So 6.5 was a major release as far as cable systems goes. On the Earthworks front, 6.6 is a fairly big release as well. We've added soil layers. So soil layers is a new tool that allows you to set different compaction layer and soil volumes within an earthwork zone. You could, for example, have a top layer that is more compacted and is harder to dig through, which would be followed by a softer layer that would be easier to dig through underneath it. You could also use it to add soil piles or soil content above ground. For example, as we see in the picture here, we have a soil pile at the start of the scenario. As we'll see in a moment, you could use it to create new training scenarios as well. Some new soil tools were also added to Earthworks in 6.6. The soil emitter is one of those. It allows you to generate new soil particles to simulate the tools, for example, such as a concrete bucket or a hopper. The soil culling geometry in its end removes existing particles along a specified geometry. And with both of those, what we've done is we've added sensors that allows you to check with the soil culling sensor if there are soil particles passing through your specified geometry. So is it removing soil particles? The soil mass sensor on its side keeps track of the mass of soil that is passing through the new soil emitter tool. So we're going to show you the new soil layer tools in the updated Vortex Earthworks sample that is shipping with 6.6. So I'll pass it back to Marc-Alexandre.
A number of new tools have been added to the earthwork modules in Vortex 6.6. Among them, the soil layer tools now allows you to create zone of various compactness within an earthwork zone. In this case, we've used it to fill the bed of the truck with soil. As you can see, it can be dug into just like the soil on the ground. Other tools include a soil emitter, soil culling geometry and monitor, and a soil mass sensor to help you determine how much soil you have loaded.
And there we go. So the compaction level of that soil has been adjusted elsewhere. So we have the 3D work here, we have the soil layer extension here, and I've set the density to 50% of the soil in the rest of the scene. And there's a box inside the dump truck itself that delimitate where the truck is loaded. There's also the various other tools that GP was talking about are accessed through the Earthwork button here, so you can set an emitter, a geometry, a monitor, and so on. Back to you, GP.
Thank you, Marc-Alexandre. So moving on, this brings us to the marine systems, which saw significant change in 6.5 and 6.6. So in 6.6, the changes we've seen, the improvements, are mostly related to visuals. We've added a new propeller wash effects, which simulates the wash created by a vessel's thruster. So this is what you see here, which really conveys a vessel's motion a lot better. And we've also added support for water decals. Water decals are interesting because they allow you to simulate effects that are fairly varied. What it is you add images to the surface of water, and those images will actually track the motion of the surface, such as the waves, for example, and will move with it. This allows you to create, for example, splash effects, but it could also be used to simulate oil or blood that is on the surface of the water. So this is good to add different scenarios, and using the water decals tools, you could make it so, for example, the oil spill grows over time. 6.5 saw improvements to visuals as well, and those were significant. First, the ocean surface reflection was upgraded significantly. The surface reflection added reflections for the surrounding environment elements. That includes the sky dome, the objects, and the lights. So what you see here is in 6.4 what your ocean would look like. In 6.5, you get a lot richer reflection. You can actually see the ships. If you had the sun, you would see sun reflects in there. This really enhanced the realism and the immersiveness of the scene by leaps and bounds. The other major change was the addition of horizon haze. So in 6.4, the horizon would blend with the sky along a straight line, which was not the most realistic way to do it, and it was also sometimes hard to distinguish the horizon from the sky. So in 6.5, with horizon haze, you could actually see a major improvement where the horizon kind of blends in with the sky once you get outside of the field of view. You can control the distance, the fog distance in the editor to create different effects. So you could create shorter visibility or longer visibility with this. So we're going to take a look at the offshore sample that is in 6.6, which includes all of these changes, and you'll see that it has been expanded to include a lot of content also below sea level, which really makes this the biggest sample that is coming with 6.6. Marc-Alexandre?
The offshore sample is one of the largest ever offered with Vortex and is almost brand new for 6.6. It allows us to illustrate new features such as the prop wash and the ship wake. The sample includes topside vessel, as well as a subsea field, an ROV, tether and cables, deck operation, grasping and tools, lift operation, and if you have the Simulink add-on, an optional heave compensator that you can try out. Back to you, GP.
Thank you, Marc-Alexandre. So for those of you who are going to upgrade to 6.6, the offshore sample is probably a great sample to look at. You'll get all the details of the different components, the cameras and the modules that are used in the sample guide, and it's really something you can spend a good amount of time and learn a lot about the different capabilities of Vortex in. So to close the add-on section, I'd just like to talk real quick about vehicle systems. Some improvements were made available in 6.5, which was support for pivot steering and crab steering. This is really for vehicles that you want to be able to turn on a dime or move the wheels in the same direction. These are typically available on forklifts, for example. All right, so this brings us to the Vortex player. So Vortex player saw some improvements in 6.6. The main one being an update to the console to better match the look of the other Vortex application. It went from what you see here in 6.5 to the same color scheme, same style sheet, and the same visual language as you see in the editor. So this is a lot more familiar for somebody who works with the editor, and they will find their way around a lot more easily. Now, the other main change in 6.6 is the addition of a keyframes interface. So as we'll talk about in the SDK section, the keyframes API is a new API that allows you to save the positions of objects and the different dynamics elements during a simulation. Now you can save those positions and multiple of those positions, and you can then restore a previous position directly from the player console. This can be used to explore different scenarios. For example, if you're trying to figure out the best, most efficient route to move an ROV through a work site without having tether snags, you could restore a previous section, try a different way, see if it works better. This also allows you, if you're using the Vortex player, to restore a previous state in a training exercise. So we're going to look at it in action with the mobile crane sample that is shipping with 6.6, which is a good way to show the dynamics that are saved during simulation. So Marc-Alexandre, I will pass you back the control.
Let's take a look at the new Vortex player. I've selected the mobile crane sample and loaded it using the load button. Now that it's ready, I press the play button to activate it. Going into the second tab, I can access the keyframe functionality. I'm going to clear the currently saved frame and start new ones. Clicking the Save Frame button creates a keyframe. Let's get the hook moving, and I will save a few more keyframes as it moves about. At any point, I can go back to a previous position, even the start if I want to. I can remove keyframe that I don't need anymore, or even clear the complete list. You can also start a new list if you wish to save keyframe in a separate folder.
Thank you, Marc-Alexandre. So one thing to note is that the keyframes can save dynamic properties during the simulation, except for the Earthworks module. There are too many particles, too many parameters, so at the moment you cannot save keyframes that include the state of an earthwork zone. But it does work with the other dynamics properties. So if we look at the other improvements that were done to Vortex on the framework side, well, we've just talked about how keyframes work in the player, but the keyframes are actually a new API added to the Vortex SDK. So you can use this to, as part of other simulators that are built using Vortex. We've also added more granular control over the detection of collisions between different types of objects. You can now turn on or off the detection of collision between animated objects and sleeping objects, or animated objects and other animated objects. This can be useful if you're creating a simulation that is really pushing the processing limits of your hardware, and some of the collisions are not necessary to the accuracy of the simulation. So you can get more out of the same processing by tweaking those to your use case. And asset instancing, which we've spoken about in the editor demo portion, is also available through the SDK. So you can instance meshes, textures, materials, and this leads to significant memory savings and performance improvements. Every time you instance something that is present more than once, it means you will only load it once to memory, and you're going to see a gain in efficiency. One last element I'd like to talk about is that Vortex applications and libraries are now able to run on Windows 10. So if you're considering moving to Windows 10, this is good news. So we support Windows 7 and Windows 10 in 64-bit since 6.5. So 32-bit is no longer supported. We're almost at the Q&A session, so just before we get to that, I'd like to talk about the documentation that is available with Vortex 6.6. The first one is an updated user guide, which is now available in HTML5 format. This makes it a lot easier to search and navigate the user guide compared to the previous version. There is also the samples guide, which is probably a underused document because it contains a lot of information about how each of the samples we've spoken about are constructed and the different elements that you can get familiar with in there. Product specifications were updated with 6.5 and 6.6 features, and the release notes that are available also include information on new features. The last two documents, the validation verification guide and the theory guide, have to do with the science behind Vortex, and these are great if you're trying to validate the fidelity of your simulation, how you can go about to validate your model is working right, and how we model, for example, earthworks or cables in Vortex. The list of sample scenes that are coming with Vortex 6.6 is now very extensive. There is the defense vehicle scene, which has been available since a few versions, which includes multiple military vehicles in a fairly large environment on which you can drive on different types of terrain. For example, grass, you can drive on ice, snow, ground, concrete. The excavator and dump truck scene, which we've updated with the new compaction layers, is available as well, and it's been improved visually with speed tree assets. The EOT scene has been updated significantly. It really showcases the new emissive texture support in a very striking way because it is now a night scene that includes a lot of emergency lights on vehicles, and all of these are using the new emissive textures that are supported in 6.6. It also features a tether cable for the EOD butts, so this is a good scene if you want to get familiar with the use of cable rings. The forklift scene has been updated, especially on the visual side. It takes advantage of all the improvements we did to lighting in 6.5, to a lot of the new visual fine-tuning properties available in 6.6, so you'll see it is a lot more immersive. Now, the forestry forwarder is a brand new sample that we've seen in action today. It probably includes the most complex mechanism in the samples with 6.6, so it's a great scene to go and explore how that sample is put together from a collision geometry's perspective, from a constraints perspective. The mobile crane was updated with new visuals, so it looks a lot nicer. But it is probably a classic staple at this point of the Vortex samples. So if you've never looked at it, it's going to be a good starting point as well. The offshore scene, which is now the biggest sample that we have in Vortex 6.6, which includes both topside and undersea elements. And a new scene that is kind of a bit of a different approach, which is the engineering parkour scene. This one is more of a toolbox in which you can use different elements to build your own parkour to test different types of vehicles or prototypes on different types of terrains. This is also a great way to get familiar with scene creation in Vortex because all of the different elements can easily be copied and moved about. So this concludes today's presentation. We're now going to move to questions which you can ask using the GoToMeeting interface. If you're leaving us, I'd like to thank you for joining us today. We really appreciate the time you spent with us. And we will be sending a link with the presentation materials, the YouTube video, as soon as it is available. So on behalf of all the team here at CM Labs, thank you for joining us. So the first question that we've received, I'd like to ask Marc-Alexandre is, so we're going to go all the way back to the start of the presentation when we looked at the CAD Optimizer. So one of the questions we got is, what happens if you do not defeature a CAD model? Are you obligated to defeature it?
Well, you don't have to defeature the CAD model. The reason we do it is to reduce the number of draw call that the computer has to do when it recreates the visual of the scene. The more nodes you have, the more work the computer has to do, and therefore the slower the simulation will run. If you make sure that you only include the graphic nodes that are needed to showcase the model and how it moves, you'll ensure that you have a high performance for the simulation itself.
Thank you. So from a so one of the questions that came in also is about terrain editing. So is there any new feature related to terrain in 6.6?
At this time, terrain is still the same as in previous version. We're looking into it to improve the terrain.
Right now, the main improvements
are related to the earthwork zone and the earthwork tools.
Thank you. I'm seeing some mention from some of the attendees that some portion of the live demos were a bit laggy. So if that happens, it's because of the streaming. We apologize about that. It is fairly bandwidth intensive, but the video version will have smoother playback. So we'll make sure to send a link, and if you have any issues with even the video version, let us know, and we'll make sure to send you a version that will showcase the new features more smoothly. So the questions that are coming in seem to be a bit more related to specific use cases and projects. So we will be taking questions in private. We'll reply by text for the next 5 to 10 minutes. And if you have any questions after the end of this presentation, feel free to send them our way at webinars@cmlabs.com, and we'll get back to you very fast. Thank you again for joining us today, and we hope to see you at our next webinar.